Okay, so 10.1, operations with matrices. We are going to add, subtract, do scalar multiplication. We're going to be doing things with matrices. Matrices are a nice, clean way to do things. We've done Gauss-Jordan elimination. Those were matrices. Okay, now we're going to do more with them. Okay, a capital letter is used to refer to the entire matrix. So you don't really need to write all this if you don't want, but we name with a capital letter. So if I say matrix A, I'm talking about every single thing in matrix A. A specific element can be referred to using the subscript. Again, guys, all this information is just knowledge based. I'm not going to quiz you on it. Does that make sense? So this is row G, column J. So this element is A sub GJ. See that? It's row first, then column. So this element here is A, G, K, because it's row G, column K. Rows always come before columns. Think about if I were to construct a building. Even if I want to construct a column, don't I have to start at the bottom? So my rows stacked make my columns. So it's always rows first, then columns. The subscript list for the rows, numbers, and column number of a matrix, we have A sub 3, 2. So that is row what?
A.
Row 3, column 2. So row 3, column what? 2. So that element would be right there. Make sense? Okay, refers to the third row, second column. In this one, we have row 3, 1, 2, 3, and column 2, 1, 2 would be what number? 8. Make sense?
Yes.
Did you need all those words to do that? No. Am I good to go?
Yes.
Okay, so a way we can do matrices is using word problems, your favorite thing in the world to do. And just look how this is made up. It says, Cool Threads, a clothing company, uses a matrix C to represent the price of women's clothing. So I have matrix C, probably for cost, maybe. We have 320, 210, 160, 240, 110, 65. The columns represent the brands, vintage, casual, or distressed. So vintage, casual, distressed. And the rows represent jeans and jackets.
Do you want us to write this out?
Well, this is an example. I don't know if I'd write all those words, but I would definitely write the matrix. So we have jeans. And then jackets.
That says jeans.
Yes.
Looks like not jeans.
Well, it says
Oh,
jeans.
Okay, I see it now.
Okay.
Jeans. Oh, weird.
I know my dot went off.
It looked like an RAN.
Oh. Okay, so unless it tells you like the first row is this and the second row is this, you name them in the order that they're said. Does that make sense?
Yep.
Okay, because so they said vintage, casual, distressed, so you went vintage, casual, distressed, left to right. It said jeans and jackets, so we did jeans, jackets, top to bottom. So now, if the sales tax rate is 5%, how can you use matrix operations to find the amount of sales tax? Well, if I wanted to find the tax on any one thing, if I said something was $5 and it was 10% tax, how would you find it?
5 times 1.
Right, you'd take 5 times 0.1, right? So we need to multiply everything in this matrix by what? 0.05. So what that is called is scalar multiplication. So what we're going to do is put 0.05 0.05 times 320 So we're basically going to multiply by 5 and put 2 decimal places in. Yes? So this is scalar multiplication. So that means I multiply every single thing in here by 0.05. That's what that means. So I have 0.05 times 320. 16.
16.
That says 16. And then 0.05 times 210.
10.5.
Okay, and then 0.05 times 160.
8.
0.05 times 240.
12.
0.05 times 110.
5.5.
So we all see that as $5.50, yes? Okay. And 65 times 0.05?
3.25.
3.25. Okay, so what we just found, so this was a cost matrix, correct? With 2 S's evidently. That's a cost matrix, yes? What was this? The new one?
Sales tax.
Sales tax. So we took the percent of sales tax times the cost, and it equaled the sales tax, yes? How would I find the net cost? Like the whole cost, the gross cost. There we go. Say that again. Okay, so if this matrix here was C, we named it C, right? Can we name this one S? So if I took C plus S, this is what I'm doing, right? Now, in order to add or subtract matrices, they must be exactly the same size. Remember we talked about size before, the dimensions. What kind of matrices are these? What are the dimensions of these two matrices? What by what? 2 by 3, rows by column. So this is a 2 by 3, and this is a 2 by 3. So we could add or subtract them. They have to be exactly. So what is our total cost then? How much do vintage jeans cost with tax?
$336.
336.
So do you add the whole, like,
Yep, you add each element.
I'm not
So you'd add
336 bucks.
16 plus 320?
Yes. Because this is the cost of the vintage jeans, and this is the tax of the vintage jeans, isn't it? Okay, so how much do casual jeans cost? $220.50. How much do distressed jeans cost? $168.
That is too much money. Nice, $20.
How much would a vintage jacket run you?
$252.
$252. How about a casual jacket?
$115.50.
And a distressed jacket.
$3.25.
No, how about $68?
Oh,
You forgot part of it.
yeah, I forgot to add it.
Okay, I ran out of room. Do you see how this can help a lot? Do you deal with matrices actually a lot in science?
I guess.
Those tables they give you are matrices. We also call them an array of numbers. But matrices can be really valuable. Computers work really well with matrices because you can set them up and they can do all the math. After you do everything by hand, I will teach you how to use your calculator to do so.
All I was paying $336 for jeans.
Somebody who makes a lot more than me.
They were a nice $20 pair of jeans.
Because I
Or a
wear
pair of Levi's.
Nice and
if
you're
they're
rich.
Okay, Levi's are like almost $70. So
I'm saying Levi's on sale.
okay.
Or the only time I get-
Okay, so what we just did was called scalar multiplication. We scaled every single thing in that matrix, didn't we? We can scale it up or we can scale it what? Down. If we multiply by a whole number, or a number greater than 1, we are increasing the size. If we are multiplying by a number less than 1, we are decreasing the size. Now, this was just the example that I just did with you. It was going to do 6% tax, so we'd multiply everything by what? Not 0.06, not 6. If I wanted to figure out the price including tax, I'd do 1.06, wouldn't I? Where'd the 1 come from? 100%. Just like when we did our interest rate, wasn't it? So if I wanted like the total cost, if I wanted to jump to the total, I could do 1.06 because that would put the original price plus the sales tax. It would do all of that math at one time.
So like that's one that we just did?
Rather than doing it, multiply it, and then add it. If we did 1.05, we would have got the bottom numbers. Okay, are we all good? Okay. Cool Threads uses the matrix above. You see these two matrices up top? Okay, we have vintage, March sales on the left and vintage April sales on the right. To keep track of their monthly sales, matrix A and B, row 1 represents jeans, row 2 represents jackets, just like before. With the columns being vintage, casual, and distressed. What is the sales total for the 2 months? So how am I going to find a sales total for the 2 months? You would add them. So we would do A plus B. Well, first of all, can we do it? What do we have to know to be able to do it? They have to be the same. They have to be the same size, right? So what size is the left? 2 by 3. And what size is the right? 2 by 3. So can we do it?
Yes.
If it's not exactly the same, you say undefined mismatched dimensions. That's it. Okay, so what is A plus B? 14 plus 18 is 32. 28. How about you do it? I'll do it. We better get the same answers, right?
Yes, ma'am.
We're just adding the corresponding elements.
I'm writing them out so I know.
Okay, that's fine. If you want to write it out. So what was the total sales for casual jackets? 24. That's it.
So would it just go vintage casual?
Mm-hmm. So vintage, casual, distress,
Where is it?
jeans, jackets. Because they don't change positions. That's why you have to have them completely matched up. Does that make sense? Because With matrix multiplication, there's a bigger process involved, but with addition, subtraction, it's just,
Are we not yet time to
on this one, no. We are gonna multiply on Wednesday. It's not up there yet, but we are gonna multiply on Wednesday. We're just doing the addition, subtraction, scalar multiplication the next 2 days. Okay, so what is the difference in the number of items sold each month? Subtract them. Okay, so do you want to go from March to April or April to March? Which way? I think we do April. You always do like this month compared to last month, right? Don't you? So B minus A. Because if I want to know the change over the 2 months, I always go with the closer one, right? Riley, wake up.
Jeez,
Are you doing these problems?
Yeah.
Okay, so B minus A.
What do you even subtract?
The numbers.
What?
So
No.
18 minus 14.
Oh.
17 minus 11. 25 minus 28.
Okay.
I'm like, you had me confused.
I didn't know if you were like subtracting that other numbers.
Well, that's why I have B minus A.
I have some negative numbers.
Yep. So if you get a negative number, what does that mean to your sales?
The negative.
They're negative sales. You didn't sell as many, huh?
You didn't make as much.
How is 17 minus 11 3?
Yeah.
Yeah, because it is.
It's what? Can you prove that, please?
Yes, I can. Prove that it's not. How about that?
Whoa, it turned into a 6.
So I got 4, 6, negative 3, 6, negative 6, 10.
Yes.
So what can that tell me?
Negative. For the most part, your sales are up.
For the most part, sales are up.
No.
What sales are down?
Distress jeans.
Distressed jeans and casual jackets. And I'm not selling very many of casual jackets in the first place, am I? So could that say, well, maybe we don't want to sell that anymore?
Yeah.
Yeah. Because what went up the most?
Distress.
Distressed jackets. So maybe I need to carry more distressed jackets and less casual jackets, right? Now, I mean, I don't know if I'd do anything with distressed jeans. Would you? Are you still selling quite a few of them?
Yeah.
Yeah. You're still selling. I mean, it's the second most thing I'm selling, isn't it? Yeah. It went down a little bit.
Okay, summertime.
So, is there a lot I can do with this? And it tells me I could make some decisions on it, couldn't I?
Yes.
Do people actually use these?
Yes, they do. Okay, so then we have basic operations. So do M plus N. Oops. Do these real quick, guys. M plus N and N plus M.
Is it the same?
Huh?
You're confused.
No. I'm confused.
What?
Because it's only a 2 by 2.
But are they the same?
Why do we have to do?
Yeah.
Yep.
Addition is always the same. Yeah.
You don't know that.
Yeah.
Isn't multiplication always the same?
No. Well,
Yeah.
Yeah, but in matrices it's not.
Why?
You'll have to see. So prove it to yourself that it's the same for addition. Just prove it. Multiplication isn't always the same.
Yes, it is.
we have two numbers down, one numbers and
Doesn't.
I'm getting myself really confused, Miss Mick.
Why?
I don't know because I don't know.
Negative 8 minus 2. You would do then.
What?
Well, I didn't do
Why
any
did you do
minuses.
minus?
That's what I did.
We're adding.
See, that's what I told
Adding.
you.
Basically. Subtracting.
But we're not subtracting. They're both
Subtract
addition.
to get the first one.
What?
Like the 2 minus 2 plus 8, I got negative 6 out of.
Yes.
So basically, I'm subtracting.
Oh, you weirdo.
In my brain.
Okay. Don't talk anymore. You're confusing me. Okay. So is matrix addition commutative? Yes. Okay. Is real number subtraction commutative? No. And is matrix subtraction going to be commutative? No. Addition is, subtraction is not, just like real numbers. When we do matrix multiplication on Wednesday, I will show you in general, it is not commutative. A times B is not usually the same as B times A. If it is, then they're special matrix. They're matrices. Okay, so again, note to self, what has to happen to be able to add or subtract?
The same column.
They have to be the same dimensions. They have to have the same number of columns and rows.
No, Carly.
Which matrix, I'm just asking some general questions. Which matrices can be combined using addition subtraction? So let's go through and dimension them.
ADC.
Okay, so wait a second. What's A?
Actually, all of them.
What's A?
No. 2 times 3.
2 by 3. What's B?
3 by 2.
3 by 2. What's C?
2 by 3.
2 by 3.
2 by 3.
2 by 3. So we can add, subtract
A,
A,
D,
D, or how about A, C, and D?
yeah.
Okay. Why cannot B?
It has an extra row and one
Right.
less column.
It both has a 3 and a 2, but do I have the same number of rows and the same number of columns?
No.
No. Which two matrices would give you a 0 matrix if you added it? 0 matrix has all what?
A and D.
0 matrices have all what?
0.
Zeros.
A and D.
A and D?
Yeah.
Why?
Oh wait, yeah. Because 5. Negative 5.
'Cause they're-
Negative 7, 7.
They're opposite signs, right?
Yeah.
So A plus D. But if I subtracted them, would they?
No.
No, because the negative would distribute, wouldn't it?
Yes.
Okay, how does A plus C and C plus A relate?
It's a cumulative. It's cumulative.
They're commutative,
Everyone.
so they are what?
The same either way.
Are they equal?
Yeah.
Yes.
What?
So A plus C would equal C plus A?
Yeah.
Okay,
What?
what is the additive inverse of B? Oh no. If I want to add the inverse, I get what? What do I get when I do the additive inverse?
1.
If I do, shoot. If I do x plus 2 equals 6, what do?
It's a minus.
You minus 2, right?
4.
Because that's the inverse operation to addition is subtraction, yes?
Yeah.
So what do I get when I use the additive inverse?
You subtract.
But what do I get?
The negative.
What is positive 2 minus 2?
0.
0. So what would be the additive inverse to B? So what would I use to get 0?
Negative 6.
Negative 6,
5. Positive.
negative 5,
0.
2, 0.
3 and 4. Oh. Okay.
Okay, so an additive inverse gives you what?
The same thing, but different sign.
Right, but what's the result?
0.
The 0 matrix. 0 matrix is just what?
0.
0. If you ever have it and it does, they write it like this, what does it mean a matrix full of?
0.
Zeros. Okay? That's it.
Yay.
Don't delete that.
Do I need to go back?
Yeah, I just want that so.
Noah's got a paper.